How does nanomedicine help cure brain diseases? Our brain is precious, delicate, and crucial for our everyday activities. For this reason, it is protected from the skull and from complex cellular systems and membrane, like the meninges and the blood-brain barrier. Meninges are three membranes layered on top of each other that isolate the brain from external environment and make it inaccessible for pathogens such as bacteria and viruses coming from the outside. The blood-brain barrier protects the brain from molecules coming from inside the body through the blood. Whatever circulates in our arteries and veins has to cross this barrier before entering the brain. This barrier acts as a security gate against foreign particles. This is fine for most things that we might ingest, but it represents a terrible obstacle for drugs that would otherwise cure the brain. Current problems with therapies against brain diseases are, indeed, their inability to target the site of lesion. This is where nanomedicine can help. Traditional drugs cannot cross the blood-brain barrier because they are too big to diffuse through this security gate. On the contrary, nanomedicine implements nanocarriers that can transport drugs throughout the body and are designed to be small enough to cross the blood-brain barrier, passing from blood to the nervous tissue and delivering the drugs to the brain. Nano refers to things that are very small, around 1/1,000,000th of a meter, invisible to eyes, and also to most microscopes and laboratory instruments. At the same time, these nanocarriers must not accumulate in other organs. Hence, they have to be designed to precisely target the brain. How can researchers prepare such a nanodrug? The most common nanocarrier for drugs are liposomes, tiny vesicles surrounded by lipids that isolate the internal core from the surrounding environment. The lipid surface is useful to hide the drug molecules from the immune system and cells that constitute the blood-brain barrier, and also from other scavengers present in the body. More importantly, the lipid surface can be designed with protein molecules that direct the nanoliposomes to the target site, which in this case would be the brain. This is a promising strategy expected to shed new light and hope on the therapeutic approach for neurological disorders, like neurodegenerative diseases and brain cancer.